Here we go. We have a question, rotate a linked list. So you have given the height of a single linked list. Your task is to left rotate the linked list k times. So you have given this linked list and we need to rotate on the left hand side k times. So first of all, in the first step, the 10 will move on the last side move. Then we have this is the answer after first rotation. Then 20 will move, then 30 will move, then 40 will move. So this is the last answer after k rotation, which means 4 rotations. This is our answer. So we have the same linked list, but k is more. So in our first step, 10 will move, then 20 will move, 30 will move, 40 will move, then again 10, then again 20 will move. So this is the answer. Now let's build the approach. So the brute force can be like we have this node. So we will remove from the head side and add on the last side. So it will take order of n for our first rotation. So if we have k rotations, it will take order of n cross k. But we can optimize this. We just need to return the answer. First of all, if our k is more, so let's say our k is 6. So k is obviously greater than length. One observation is if our k is equal to length, if our k is equal to length, our 10 will move, then 20 will move, then 30 will move, then 40 will move. Again, we have 10 as our front side. So if k is equal to length, we don't even need to rotate the linked list. We don't even need to shift the nodes. If our k is equal to head. So if our k is more than head, we just need to find how much value is more. So in this, what I will do is k will be modulus with size. So then we have 2. Only we need to shift 2 nodes. Only we need to shift 2 nodes. This is the head and we need to find our new head. So first, then second. This will be our new head. After second rotation, after 2 rotations, how this 10 will move, this 20 will move, then after 2 rotations this will be our new head. The head stays on this on its position. We just need to shift 2 nodes. We just need to shift 2 nodes. So let's suppose let's take an edge case. If our k is equal to n, if our k is equal to n, it means all the nodes will shift and we still have 10 as our head. So if our k is equal to n, or after a modulus, if our k becomes 0, so let me write it here. If k is equal to 0, just return your original head. Then if this is not the case, we first need to find the new head. But before finding the new head, this will be our answer. But some value, some node is already pointing to this value. So we need to first disconnect this connection. We first need to remove this connection. That's why it is crucial to point, it's crucial to find the previous new head. Means new head previous. We need to find new head previous. Why we need to find this? To disconnect this link, to remove this link. So that's why we need to find new head previous. New head previous. So we need to find this node. So how many times we need to jump? So we need to jump k minus 1 times. So if I jump k times, first jump, then second jump, we will reach to new head. So if I jump one less time, So this will be my new head previous. This will be my new head previous. This will be my new head previous. So I jumped k minus 1 times. Then I reached this node. So first thing when I reach this node is to first of all save this node. So just make new head. So our first step, what's the first step? First step is to find new head previous. Then the next step is to save new head. Save new head. Then the third step is to disconnect. So just disconnect this. Then we have this node. We have our new head. Then we have two separate linked lists. First linked list is this. Second linked list is this. We need to attach this node after the last node. Then just return your new head. So we need to first find the last node and connect head node after the last node. First step is to we have this, we have disconnected the link. Then the next step is to find the last node. Find last node. So this will be my last node. After the last node, just make a connection to head. So then connect to head. So after connecting to head, we just need to return new head. We just need to return new head. So if I return new head, then let's iterate it here. First it will print this, then it will jump to the next node. So we will print this, then it will jump to the next node. We will print this. It will jump to the next node. We will print this. We will jump to the next node. We have null. So what will be the answer? 30, 40, 10 and 20. So we have 30, 40, 10 and 20. So this will be my approach. In this, the worst case will be order of n. So I will tell you. So before that, let's build the code. Let's write the code. So we have first length. First step is to find the length. So we have this. I applied for loop. You can also write for each loop. On every step, I am incrementing size variable. Here, the size variable name is n. N means number of nodes. Then just modular with n. Just modular your k value with n. If your k is 0, it means we don't even need to shift the nodes, just return the input head itself. After that, we need to find the new head previous. Remember, we need to jump only k minus 1 times. So we have find node function. I am passing head node and we will jump, and also passing k, but we will jump only k minus 1 times. So we will jump only k minus 1 times till our k is greater than 1. If our k is greater than 1, we will decrement our k value and jump to the next node. Still our k is greater than 1, jump to the next node. K is greater than 1, jump to the next node. So after that, we have reached k minus 1th node. It means new head previous. First save your new head previous dot next. So first save this, then disconnect the connection. So we have dot next value will be null. Then we have two separate lists. First is the head, second is the new head. We need to find the last node. So we have last node on the other half, on the second half. So we have new head function, new head pointer pointing to the second half. So I am passing new head in our function find last node. So this is my find last node. while current dot next not equal to null, it means current is pointing to the last node. So after reaching the last node, just make a connection to the head node, then just return your new head. Is that simple? Let's submit this. Let's talk about time and space complexity. So we have a length function, it will obviously take order of n. We have find node, so in the worst case it will take order of n minus 1. So overall it will be order of n plus n plus n. So you can take out constant. So our space complexity is constant and time complexity is order of n. We have reached the expected time and space complexity. Thank you all for watching this video.